Hello everyone, today we are going to discuss about Unit 3 aperture and frequency independent antennas. So this is the syllabus: frequency independent antenna, spiral antenna, helical antenna, log periodic antenna, AWP antenna, aperture antennas and horn antenna, parabolic reflector antenna and microstrip antenna. And generally frequency independent antenna, which is nothing but the antenna will be independent of frequency. The working principle of antenna will be independent of frequency. The frequency independent antenna is a physically fixed antenna in size and operates over a wide range of bandwidth, and it is relatively constant impedance, pattern and polarization, and high gain. So these antennas are broadband antennas which are using 10 to 10,000 megahertz, and the frequency independent antennas are works under the basic principle of Ramsey's principle. The principle states that the impedance and pattern properties of a lossless antenna is independent of frequency if the dimensions of the antenna are specified in terms of angles such that they remain constant in terms of wavelength. So the impedance and pattern properties of the antenna, which is nothing but the radiation pattern properties and impedance properties, are independent of frequency if the dimensions of the antenna is measured in terms of angles and in terms of wavelength also. So this is the basic structure of our spiral antenna, and this is the various kind of spiral antenna we are having: two spiral, multi spiral, and this is the conical spiral antenna. Alpha values increasing and alpha values decreasing, and this is the two unbalanced conical spiral antenna. No something but helical antenna. A helical antenna is the simplest type of frequency independent antenna. It is going to provide circularly polarized waves, and these antennas will be used for broadband applications like VHF and UHF. And the construction, if you are going to think about the construction of a helical antenna, so this is the structure of a helical antenna. The antenna is fixed on a ground plane and it has a number of turns, and it considers the slow wave structures, and we are going to give the input through coaxial cable, and the inner conductor is connected with our helix and the outer conductor is connected with our ground plane. And so these are all the various forms of our practical helical antennas. These are the various structures, and these are the various structures of practical helical antenna which is used for producing circularly polarized waves. So these are all the various structures of helical antennas, various shapes and various types of helical antennas. And this is the radiation pattern of our helical antenna, and these are all the notations which will be used for analyzing helical antenna. C is circumference of helix, D is the diameter of helix generator, A is the actual length, N is the number of turns, L is the length of one turn, and L is the spacing between the helix and the ground plane, and alpha is the pitch angle. Thank you.